Insertion algorithm for doubly linked lists. The above diagram shows the doubly linked lists or DLL. A doubly linked list, DLL, contains an extra pointer, typically called the previous pointer, together with the next pointer and data which are there in the singly linked list. It is the Python implementation of a doubly linked list. It has class name as node self. Next is equal to next is the reference node to next node in doubly linked list. Self.prev is equal to prev is the reference for the previous node in doubly linked lists, and self.data is equal to data as reference for data node which stores the value. In doubly linked lists, insertion takes place in three ways. They are insertion at the beginning, insertion at the specific position, insertion at the end. The insertion at the specific position takes place in two ways. One is after a given node and the other one is before a given node. We need to insert an element at the beginning. The first node will be the head. In order to insert a node at the beginning, we want to make a link between new node and first node. In the doubly linked lists, the diagram shows the head of the provided linked list is always appended before the new node. The newly added node serves as the DLL's new head. For example, in this case, if we add item 5 to the front of the given linked list, which is 1015, the linked list will change to 51015. The function that adds at the top of the list should be called push. Because the push must modify the head pointer to point to the new node, the push must receive a pointer to the head pointer. This is the Python implementation for inserting a new node at the beginning. We have to define a function push which contain an argument new data. Then we have to assign new node equals node of data equals new data, which is for assigning the node, and insert the data. Then we have to assign new node.next equals self.head and new node.prev equals none. These are for make next of new node as head and previous as null. Then we have to change previous of head node to new node for that execute the fourth step. At last, we have to move the head to point to the new node and execute the step 5. Insertion at specific position. The diagram shows adding a node after a given node. In this diagram we are given a pointer to a node as prev_node, and the new node is inserted after the given node. This is the Python implementation for adding a node after a given node. In this we have to pass two arguments. One is previous node for storing the address of the previous node, and new data for storing new node's value. First we have to check whether the given previous node is null and print the node doesn't exist in doubly linked lists. Then we have to allocate node and put in the data, and we have to make next of new node as next of previous node. Then we have to make previous node as new node and make previous node as previous of new node. At last, change previous of new node as next node. The diagram shows adding a node before a given node. In this, we are given a pointer to a node as previous node and the new node is inserted after the given node. These are the steps for adding a node before a given node. Let the pointer to this given node be next_node and the data of the new node be added as new_data. NBSP. Check if the next_node is null or not. If it's null, return from the function because any new node cannot be added before a null. Allocate memory for the new node, let it be called new_node. Set new_node GT, data equals new_data. Set the previous pointer of this new_node as the previous node of the next_node, new_node GT, prev equals next_node GT, prev. Set the previous pointer of the next_node as the new_node. Next_node GT, prev equals new_node. Set the next pointer of this new_node as the next_node, new_node GT, next equals next_node. If the previous node of the new_node is not null, then set the next pointer of this previous node as new_node, new_node GT, prev GT, next equals new_node. Else, if the prev of new_node is null, it will be the new head node. So, make head_ref equals new_node. The diagram shows insertion at the end. In this, the final node of the provided linked list is always added before the new node. For example, in the case, if we add item 30 to the end of the given DLL, which is 510152, the DLL becomes 51015230. Since the head of a linked list often serves as its representation, we must traverse the list all the way to the end before switching the next to last node to the new node. This is the Python implementation for inserting a node at the end in doubly linked lists. In this we have to pass only one argument new data. For adding a node at the end, first we have to allocate node and then put in the data. Then, this new node is going to be the last node, so make next of it as null if the linked list is empty, then make the new node as head, otherwise traverse till the last node, then change the next of last node. At last make last node as previous of new node.